This session will solve some numericals on Sumpner test. The first numerical on the Sumpner test. In a back-to-back test, the wattmeter W1 reads 4 kilowatt while the wattmeter W2 reads 6 kilowatt. Find the full load efficiency of each transformer. The transformers are rated 200 kVA. Assume power factor to be unity. Okay, this is a numerical given and you have to solve for the efficiency of the each transformer. Okay, then first you have to look into the what you have to calculate is the efficiency of the transformer, efficiency of the transformer. It is x into s into 10 raised to 3 cos phi. This is the equation. That is here he asks you to calculate the efficiency at full load. You have to calculate, that is find the load efficiency of full load efficiency the each transformer. Means at full load you want to calculate the efficiency, therefore your x should be 1. S is already given, that is 200 kilovolt ampere. That is B is extra is put here. It is mistake, topological mistake. It is a 200 kilovolt amperes. That is S is 200. And at what power factor he has to ask you to calculate the efficiencies? Unity power factor. Cos phi is 1. Okay, those things just you have to make it. And the first thing is the W1 by 2, that is the iron loss. What is the total iron loss of the transformer? 4 kilowatt. Therefore, for each transformer it is 4 by 2, that is 2 kilowatt. Similarly, the copper loss is given by the W2. Then for each transformer it is once again W by 2, that is equal to 3 kilowatt. Or straight away you can substitute in this equation. Therefore, what I am doing here is rating of the transformer is 200 kVA. That is the loading factor is x is equal to 1. The cos phi is also 1 because he is given that unity power factor and x is equal to 1. That is full load for 200 kVA transformer. What should be the efficiency? Just you have to substitute in this equation. Then what I am getting is 1 into 200 into 10 raised to 3 into 1, and it is the output plus copper iron loss per transformer, that is 2 kilowatt, and copper loss at full load is 3 kilowatt. That what I am writing here. Then if you are finding out what you are getting, the fraction efficiency is 0.9756 or percentage efficiency is 97.56%. It is very straightforward question. Just you have to write the equation for the efficiency. What are the data given? Just you have to list out and you have to substitute. Then you are getting the answer. We will move to the second numerical. The statement is two similar 250 kVA single phase transformers give the following results and are tested by back-to-back method. Main wattmeter, that is supply side, it is 5 kilowatt. Series circuit wattmeter, that is in the secondary side, that is 7.5 kilowatt. At full load current is mentioned, it is at corresponding to full load current. Find the efficiency of each transformer at 75% of full load and 0.8 power factor lead. Okay. Then what he asked is the efficiency of each transformer. Once again, you have to write the equation for the efficiency. That is efficiency is x that is a loading factor, s into 10 raised to 3 into cos phi, then x into s into 10 raised to 3 cos phi, that is the output of the transformer, and the iron loss per transformer and the copper loss per transformer. Here the loading factor x is given 75% of the full load, therefore x is equal to 0.775 and the cos phi is 0.8. Here as such there is no question of lag and lead. In the equation you have got a cos phi, whether it may be a lead or a lag, that is you have to substitute the value of the power factor given, that is 0.8 here. Therefore, first I start with once again the iron loss per transformer, that is 5 divided by 2, that is 2.5 kilowatt. That is wattmeter W1 gives the iron losses of the two transformers, while the wattmeter W2 gives the full load copper loss of the two transformers. Therefore, what I am interested is iron loss for each transformer, that is Wi, that is nothing but W1 by 2, that is equal to how much we are getting? 2.5 kilowatt. Similarly, the full load copper loss of each transformer per transformer, that is W2 by 2, then I am getting around 3.75 kilowatt. Then we know the loading factors, that is X is equal to 0.75, kVA of the transformer is 250 is given here, and at 0.8 power factor we want to calculate the efficiency. We are knowing all the data in this equation, just you have to substitute, then you are getting the answer, that is full load efficiency. What we are getting is 0.9702 or 97.02%. This is how we have to calculate the efficiency of the each transformer using the data of Sumpner test or back-to-back test. Then we will take up the another example. Here we ask you to calculate both regulation and efficiency of the transformer. That is, two similar transformers having rating 10 kVA, 250 or 500 volt, single phase transformer give the following results when tested by back-to-back method. And V1 and V2 is given, that is P1 is 250 volts, W1 200 volts, I1 is equal to 4 amperes, that is LV side, that is 250 volt side is conducted, connected is these meters, and V2 is equal to 50 volts, W is equal to 180 watts, and I2 is equal to 20 amperes, that is conducted on the HV side, that is 500 volt side, that is 400 volt side, that is HV side, this is LV side. They ask you to find the regulation and efficiency of each transformer at full load and 0.8 power factor lagging. Here, to calculate the efficiency, it is very simple. First you have to start with the efficiency, then you go to the regulation. For efficiency we need the output, that is X into kVA into power factor divided by X into kVA into power factor plus iron loss plus copper loss. Iron loss we are getting here for two transformer 200 watts. For each transformer it is 100 watts, and copper loss it is a 20 amperes. If you calculate the full load current corresponding to HV side, it comes out to be 20 amperes. Means this copper loss is calculated at full load condition. Therefore, it is full load copper loss per transformer is 90 watts. Just we'll see. And you have to write the equation for the efficiency. X, he asks you to find out regulation efficiency of each transformer at full load. Therefore, X is equal to 1. S is given 10 kVA and cos phi is 0.8. Therefore, you have 0.8. Then these are the things is given. W1 by 2, that gives the iron loss, that is 100 watts, and copper loss at full load is 180 divided by 2, that is 90 watts. Just have to substitute in this equation. What we are getting is the efficiency. X is equal to 10, X is equal to 1, it is not 0.1, it is 1, cos phi is 0.8. Suppose if you are substituting these values, then what I am getting here is 1 into 10 into 10 raised to 3 into 0.8 and 1 into 10 raised to into 10 into 10 raised to 3, 0.8, 200 by 2, 180 by 2, it is 1 square. Loading factor is 1. That is okay. What we are getting here is 0.9768 is the efficiency. Then if we are expressing in terms of percentage, it is 97.68%. This is how we have to calculate the efficiency. It is straightforward from the given data. The next important thing is find the regulation. For finding the regulation of the transformer, you have to find out the equivalent resistance and the reactance. Here he is given the reading corresponding to HV side, means the secondary side on also secondary side itself, that is high voltage side is the secondary side. Therefore you have to, from this test data you are getting RO2, XO2 and ZO2 refer to the secondary side only. How we are proceeding that one. That is the regulation equation. We know that it is I2 RO2 cos phi plus or minus I2 XO2 sin phi divided by VO2, or also it is called as E2, one and same. Here power factor is given, the full load current you have to find out corresponding to the secondary winding, RO2 and XO2 you have to calculate from the test data. Then how to calculate this? Thus you have to see. For rating of the transformer is 10 kVA, it is 250 by 500 volts is the rating of the transformer. Is given the testing data for V2 is 50 volts, W2 is 180 watts and I2 is equal to 20 amperes. It is corresponding to high voltage side. Therefore, what I am doing here is, from taking the test data once again here and calculating ZO2. How to find out ZO2? Because V2 is impressing upon the two windings connected in series and the voltage impressed upon the individual transformer is V2 by 2. Therefore, I am writing ZO2 is equal to V2 by 2 divided by I2, that is 25 divided by I2 is 20, that is what I am getting is 1.25 ohm is the ZO2, that is the impedance referred to the secondary. Then how to get the RO2? RO2 we are getting from the power loss in the transformer, that is W2 is the power consumed in two winding. Therefore we are calculating RO2 to individual transformer. Therefore what is the copper loss for each transformer we have to find out, that is W by 2 divided by I2 square. I am not making W2 divided by I2 square, here it is W2 by 2 because I am calculating the resistance per transformer here. Therefore it is W2 by 2 divided by I2 square, that is 90 divided by 20 square. What I am getting is 0.225 ohm. Ohm is the equivalent resistance referred to the secondary side. Once we know ZO2, RO2, can find out XO2. XO2 is equal to ZO2 square minus RO2 square. We have to substitute the values, and what I am getting here is 1.229 ohm is the reactance of the transformer referred to the secondary side. We know all the data. Also we know the rated current I2 is, how we are finding out, from the rating of the transformer. That 10 into 10 raised to 3 divided by 500, that is 20 amperes, that is this I2. RO2 we are calculated. Cos phi is given 0.8. Here you have to make use of plus sign because it is a lagging power factor. Minus is used for leading power factor. I2 is once again 20. XO2 you are getting here 1.2229. And sin phi is, from cos phi is 0.8. Sin phi is 0.6. And VO2 is nothing but no load voltage of the secondary, that is equal to 500 volts. Just you have to substitute those values. 20 into 0.225 into 0.8 plus 20 into 1.229 into 0.6 divided by 500 into 100. I am expressing the regulation in percentage. I am multiplying here 100. Therefore what I am getting is 3.66. This is how you have to calculate the efficiency and regulation of the transformer from the data of back-to-back test or a Sumpner test.